This is Euclid Book 1, proposition number 32. And Euclid is going to prove two things. Number one, he's going to prove that angle ACD, now first of all we're going to find ACD, this is ACD, is equal to the sum of, okay, this means that two things are going to be added together, and the two things that are going to be added together are the number of degrees of two angles. Well, the first angle is CAB, so the sum of this angle here plus the sum of ABC, which is this angle here. So the number of degrees in this angle plus the number of degrees in this angle is going to equal the number of degrees in this giant angle right here. So, what does Euclid do first? He tells you to make a triangle, ABC. Here it is, ABC. And then he says, I want you to extend the base out to point D, which we have. And then he says, the first thing I want you to do is I want you to draw a parallel line right here. It's going to start with point C, and it's going to go through point E, and it's just going to keep going back and forth like this. And he wants you to draw this parallel line parallel to this line. Now, how will you know that it's parallel? Okay. The first thing you're going to do, you're going to turn this around just like this. Obviously, we're going to draw another triangle. Now, the first part of this triangle is right here. This line is going to stay the same. This is going to be the base of what we're going to draw. Okay? Now, this length here is going to be duplicated up here. Now, how are we going to duplicate that? That's back in proposition 1, 3. How many times have I got to tell you? Use propositions 1, 2, and 1, 3 to duplicate lines. So we're going to duplicate this line that's going to be up here. We're going to duplicate this line over here, and it's going to be over here. And when we strike arcs here and here, where they meet, you're going to draw a line from point C to this point right here, and then of course you just pick a random point E. It doesn't make any difference because we're not going to be using E. We could have put E right here at the crossover point, or we could put it out anywhere. Okay, but the point is we're going to draw this line. It's going to be parallel. CE is going to be parallel to AB. It's that simple. Now, because we know that that's parallel, we can finally go into our proof. Alright? Now, let's turn this back around like this so we can see this. Now we have angle BAC. This is the angle we're going to talk about first. See that angle right there? And it's going to be equal to the angle of ACE. That's that angle right there. And so, why are these two angles equal? Because of Euclid Book 1, proposition number 29. Alright. Now, let's go on here. He also says that ECD, which is ECD, this angle right here, is equal in size to angle ABC. And again, if I recall correctly, that is also due to proposition 129. Alright. Having said all of that, then, as you can see, ACD is the sum of ACE and ECD. So this angle here plus this angle here equals ACD. Now, we've already said that this angle is equal to this one, and this angle is equal to that one. So if the sum of these two is ACD, then we can also then say that the sum of these two angles is also the same as ACD. So the whole ACD here is the sum of ABC plus BAC. That's the way it works. Alright. Now, we can go on with this. Now, if we add ACD to ACB, we're going to get 180 degrees. All right, which is two right angles. Okay, Euclid says two right angles. We're going to say 180 degrees to kind of make it simple for you. All right, now, we've already established that ACD plus ACB is equal in size to the sum of ABC, BAC, and ACB. Okay? The sum of these three angles here is exactly the same as the sum of this angle plus this angle. It's that simple. Well, we've now established that the sum of this giant angle, ACD, plus ACB is 180 degrees. So, these three angles here, if you added them together, would be 180 degrees or two right angles. And that's what he wanted us to prove. And now we have, through Euclid Book 1, proposition number 32. Stay tuned for a future Euclid proof, because one's coming. Bye-bye.